graphing a line, you only have a few choices. One, table values. More than likely, I will not ask you to do table of values for a line. I will ask you to do a table of values for a function, because lines are kind of boring. They just kind of go straight. Functions can have nice curves too and whatnot. But I might, you never know. 2, intercepts. Do you remember how to find an x-intercept? Y equals 0. And if you're looking for a y-intercept? X equals 0. And then you plot those two intercepts and you draw your line. Generally use that when the numbers get a little bit big. 3, I could give you a point anywhere and a slope. And you should be able to graph a line. You know, plot the point, rise over run, form your line. 4, I could have you graph it from y equals mx plus b.
It doesn't make it now.
Where m is slope and b is intercept. And I know a bunch of you were not using this yesterday to graph your lines. For some reason, you were all doing table values. I want you to use y equals mxb as much as you can. If I don't say how to graph it, then graph it that way. That's the best way when you have an equation.
What do you mean?
Well, if I give you an equation with x's and y's in it and I say graph the line, usually the best way to do it is to solve for y, figure out what the slope is, figure out what the y-intercept is, and graph it as a point slope. Rather than coming up with a bunch of table values and plotting points, because that generally causes errors. All right, is that the only 4 ways to graph a line? I think so. Okay. What else you want to know? Oh, that other equation?
Yeah.
Equations of lines. How do you find them? Well, number 1, you're generally going to use this equation, but not all the time. You're not going to use it all the time, but for the most part, if you have a slope, and this is important, if you have a slope, you can always use this equation. So what line can you not use this equation with? If you have a slope, you can use this equation. Which kind of line can you not use it?
This one right here.
No, horizontal line has a slope, 0.
The y.
Vertical line. So this thing works on everything except a vertical line. Everything except a vertical line. What do you need? Well, you need a point, and you need a slope. You know, change in y over change in x. And then that thing works perfectly fine. But of course, the big need is this m. You really, really need the m. How can you use this equation? Well, 1, I can give you a point and a slope. And you plug them into this formula and you get the nice equation of a line. I could give you 2 points. If I give you 2 points, there's a sub-step. What's the sub-step? Yeah, you need the 2 points to find your slope. I could give you another line and a point. Now, if I give you another line, I'll either ask make the line parallel or make the line perpendicular. So I'll be looking for parallel or perpendicular. So you need this other line to find the slope, and then you just use the point that it has to run through. Is there any other possibilities? Point slope, 2 points, a line and a point. I think that's it. And of course, parallel and perpendicular and all that fun stuff. The ones you have to be careful about are vertical and horizontal. What is the equation of a vertical line? Straight up and down. Which one? It gets back and forth. You can't flip a coin. It's x equals. It hits x-axis. It hits it at some point. We'll call it h, where h can be any real number. So that would be a vertical line. What's the equation of a horizontal line? Y equals some number. We're going to call it k. There's a reason for hk, but it comes a lot later. All right, so that's equation of lines. What else you want to know? I mean, I'll go over some examples as we go through the class, but I want to break them down into little pieces.
When we do the perpendicular, when we get our answer, we actually we flip it and make it negative, right?
Right, like say you got a slope of -3/5. Then the perpendicular slope is going to be
5/3.
5/3. Change the sign and flip it. Negative reciprocal. Negative reciprocal. And if it's parallel slope, don't do a darn thing. Keep it exactly the same. If you end up with a slope of a half, use a half. Don't go flipping and negative. Changing a sign. What else is there? Lines, slope, and functions, right? I think that's pretty much it. Oh, linear inequalities and
We doing the retest on this one too?
yeah. I don't like the idea, but the whole point of this is you to learn it. I'll get you in 161 without retests.
Well, I'll be better prepared for 161 because I had your class before.
Yeah. I made it harder. So let's start off with boring stuff. I'm quite sure most people are good with table of values now. I'm really, because I was using it to graph lines yesterday. So what I want to concentrate on, not the intercepts, most people are good at that. That's that point slope thing. For example, graph line through -4, 7 with a slope of -4. And I'm not going to make a huge picture of this because I want to do something else with it while I'm talking about it. So if I want to graph a line that goes through a single point with a specific slope of -4, what's the first change you want to do? What do you need to change to make life a little bit easier? No formulas. This is just going to be graphing. If you're going to graph this, and I say, here's a point and here's a slope, what do you want to change? I want to make the slope 4/1. That way I can see change in y and change in x. Oh, by the way, this symbol just means change. It's just a shorthand notation for change. That way I don't have to keep writing change. There's our change in y or change in x. So the change in y is down 4, and the change in x is 1 to the right. Okay. And we can plot this. It's not hard. Down. 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know you're getting used to that computer for graphing, and it's really nice because it draws beautifully straight lines, but you're going to have to do it on paper on test day. So make sure you practice it on your homework to get those lines nice and straight. Rulers come in handy, credit cards come in handy. I mean, they're long enough to do most of these graphs. So, -4, 7, where do I go?
Down 4.
And you will get it wrong. To the left 4.
Oh, yeah.
This is x,
Yeah.
left and right. This is y, up and down. So you'll go left 4 and
Up 7.
up 7. So there's 5, 6, 7. Someplace up here. So here is -4, 7. Left 4, up 7. And then you come over here to the slope, and you say, well, the change in y is down 4. So from here, you have to go down 4. It's 2 to 5, and then 2 more, and then where?
Over 1.
Over 1. So it would land right about here. The coordinate of this point is 3, 3?
Yeah.
3, 3. And you can do it again. You can go down 4. That'll pass you 1 past the x-axis and over 1. This coordinate would be -2. I'm sorry, that would be -3, 3. This would be -2, -1. And then you can draw your line. What's that last check you should do when you're graphing lines? Do you remember? I knew you wouldn't. What kind of slope does this line have?
Negative.
It's going downhill, negative. What kind of slope do we start with?
Negative.
Negative. Make sure they correspond, otherwise one of them is wrong, and obviously the one I gave you is not the one that's wrong. All right, the other thing I want to do with this is find the equation. I want to find the equation of this line. It's not going to be a nice one. So we use the equation y minus y sub 1 equals m times x minus x sub 1. What do I know?
You know the slope, and you know y1, x1.
All right, what's y1?
y1 is 7.
So you get y minus 7 is equal to the slope,
-4.
-4. You don't have to write it as -4/1 here. X minus,
-4.
so I'm going to write x plus 4. That way I can take care of the double sign. All right, now
Distribute.
distribute. You're going to get y minus 7 equals -4x
-16.
minus 16. And finally,
Get your variables to go.
well, no, I don't. I want to y equals mx plus b.
Oh,
Personally,
so to get this rid of the 7.
I don't like standard form personally. So you get y equals -4x. Add the 7 across.
9.
-9. So if I kept going, I would have to go down 4 over 1. That would bring me to -1. And then down 4 over 1 again. That hits exactly at -9. So if you just kept on graphing, you could find that y-intercept. Sometimes that doesn't work because the y-intercept is a fraction. And it doesn't show up very nice on a graph. All right, so that's graphing a line using a point slope. That's also finding the equation of a line using point slope. I will ask one or the other. Probably the equation, because I'll have graphing everywhere else. Quick run through. While we're graphing this, let's change it just a little bit. Let's make it greater than or equal to. Then we're doing an inequality so we can tackle 2 things at once. Graphing a line and graphing the inequality part of it. All right, so you have this inequality and I say graph it. What do? Solve for y. It should be the hidden agenda in this thing. So if I solve for y, I got to move that 4x, so I'm going to get -5y is greater than or equal to -4x plus 15. Don't drop the inequality. I saw a couple people taking inequalities and changing them strictly into equals. That's great, except you're going to mess up the inequality sometimes. Or you don't put it back and all you draw is the line and you're missing the shading. What's the next step?
Divide by -5.
Divide by -5. Now, here bells and whistles have to go off in your head. You just divided an inequality by a negative. What's that do to the inequality?
Flip it.
It flips it around. So we're going to get y is less than or equal to
-4/5 x.
positive 4/5 x, negative divided by a negative. And 15 divided by -5? -3. All right, what's the slope?
4/5.
4/5. So I write it this way. Change in y over change in x is equal to 4/5. I like writing that because it tells me that the top number deals with y and the bottom number deals with x, and that's exactly what you want to think. What's the y-intercept as a coordinate? 0, -3. So, plot a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 5. And where do I start?
0, -3.
Which is where?
Down 3.
Down 3. Don't go left 3. So 0, -3 is down here. The slope is 4/5. So where do I go?
Up 4.
Up 4. So 1, 2, 3, 4.
Oh, right 5.
1, 2, 3, 4, 5. Plot a huge point. I need a third point. It's not going to be nice. So I can go back to the y-intercept and go which way? Down 4. So 1, 2, 2, 3, 4.
Left 5.
And left 5. That would bring me way over to here. What kind of line?
Positive.
No. What kind of line? Remember, this is an inequality.
Oh,
Straight. All lines are straight.
Solid line.
What is it?
Solid.
It's a solid line. If that equal sign was there,
It'd be a dotted.
dotted line. If you miss that on the test, you lose 1 point out of 5. If you miss the shading on the wrong side, that's 2 points. So that would be, if you miss the dotted and the shading, that would be 3 points out of 5. Drawing the line itself right is 2 points on its own. So be really careful that you want to get most of this correct. So this is a solid line. And there's a lot of different ways of figuring out which side you should shade. My preferred method is, this is y is less than. If you're looking at the y-axis, which way is less than, up or down?
Down.
Down. Go to the y-intercept, draw an arrow down, that's the side of the graph you want to shade. So you want to shade this side of the line. Boom, that's your solution. Makes life easy, especially when those lines are almost vertical, and it's really hard to tell what's up, what's down.
So they just follow the less than.
Yeah, go right to the y-intercept. If it says less than, go down. If it says greater than, go up, and then just shade the side of the line that that arrow lands on. So that's graphing the inequality. Find the slope, find the intercept, and go from there. There will be just a couple questions where it just asks for finding the slope of the intercept, or finding out if two lines are parallel, or finding out if two lines are perpendicular. So you'll have to go through and solve for it, figure out what the slope is, and kind of do a comparison. What has to be true about the slopes if they're parallel? They better be exactly the same. And if they're perpendicular,
Opposites.
they better be flipped and negative. Or if you multiply them together, it gives you a -1. One of the two. All right, what else is there? Nothing? Nothing?
No, just keep on going over some stuff.
Oh, just keep on going. Well, there's a lot more. I'm sketching through it right
Go
now.
back to page 1.
Oh, page 1 is boring. It's those table values. I don't want to do that.
Domain and range.
Yeah, we're going to deal with domain and range. I know which one I want to talk about there. We already did that. Concept of a function, domain and range, all that fun stuff. So, for example, if I give you m of x is equal to 5 minus 3/4 x. And I tell you to find the domain when the range is 5, -1, 14. So I give you a function. By the way, what kind of function is that? What's it called?
Conjunction.
No. What kind of function is 5 minus 3/4 x? If you were going to graph it, what would the graph look like?
Down.
It'd be what? What kind of line? What kind of graph is it? If you were going to graph this equation, 5 minus 3/4 x, what kind of graph does it give you?
Negative.
Negative what? It has slope. Therefore, it's a graph of a. What things give you slope? A line. Oh my lord. Lines give you slope. No other graphs have slope because lines are the only things that are straight. So this thing is called linear. This is called a linear function. What's the slope of this linear function? Negative 3/4. What's the y-intercept?
5.
0, 5. 0, 5. All right, now, when I give you the range and I ask you to find the domain, what should be your first step? You can't do it the way it's looking. No? No?
Just over there.
I gotta change something in the original equation, not the x. X is fine. I need something that says y. So where's y here? The m of x. So change m of x into y and you get y equals 5 minus 3/4 x. You can guarantee that this is one of the questions on the test because it actually asks a couple things that I want to know. Do you understand that the function notation is just a substitution of y? That's a big piece of the puzzle. Now, again, I gave you the range, which is a bunch of y values. If you start plugging in the y values now, you're going to have to keep solving for x. If you want to reduce your work, what should you do first? Solve for x. Ignore the numbers, just solve for x. What would be your first step of solving for x? Multiply by
4.
4. So take everybody, multiply by 4, every single term, and get rid of the fractions. So this is 4y is equal to 20 minus 3, and don't forget the x. All right, if you're solving for x, what would be your next step?
Get rid of 20.
Subtract 20. So we're going to end up with 4y minus 20 is equal to negative 3x. And then?
Divide by 3, negative 3.
Divide by negative 3. Ooh. So divide this by negative 3, divide this by negative 3, divide this by negative 3. It's not going to be pretty. Now I'm going to do a little flip-flopping. I'm going to flip the equation around and write x over here is equal to. Oh, by the way, do you remember what the word cancel means with properties of math? How do I go from negative 3x divided by negative 3 is equal to x? Okay, that's the first one. So what property is negative 3 divided by negative 3 is equal to 1?
Identity.
Nope. Inverse. And then you have a 1x, and what property is 1x equals x? Identity. Anytime you say the word cancel, the two things that are going on are in order, inverse, and then identity. All right, just a little review. 4y over negative 3 is better known as?
1 1/3.
Negative 4, oh, don't you dare use cooking numbers. Negative 4/3, y. Negative 20 divided by negative 3 is better known as? Positive 20/3. Oh, this isn't looking good. Lots of fractions. I wonder if I screwed up.
Yep.
No, I didn't. At least I don't think I did. All right, so we're going to start off with these things. Remember, range is a bunch of y equals. So if I plug in y equals 5, we're going to get x equals negative 4/3 times 5 plus 20/3. Ooh, fractions. Wonder if that'll be on my test.
Yes.
More than likely. What's 4/3 times 5? What should I do with the 5? Well, I put a 1 under it just to be safe, so you don't do anything weird. Negative 4 times 5? Negative 20. 3 times 1, of course, is 3, plus 20/3. Woohoo!
0.
What property? Inverse. Additive inverse. This is 0. So one of my values for x is 0. Yay. That wasn't that bad. Let's choose negative 1. So we'll go x equals Negative 4/3 times negative 1 plus 20/3. This one's a little easier. What's negative 4/3 times negative 1? 4/3. So we'll get x equals 4/3 plus 20/3, better known as
24/3.
24/3. I won't.
Which is 8.
Which is 8. Hey, that's a nice number too. I wonder if they're all going to be nice. Let's see. 14. It's a little bit bigger, but x equals negative 4/3 times 14. I'm going to put it over 1. Plus 20/3. All right, 14 times 4. 56? Okay. So this is negative 56/3 plus 20/3. Better known as? No.
Negative. Oh, no.
It'd be negative 36/3. So this is negative 36/3, better known as?
13.
What? 13, no, 12. You ever see the Monty Python movie, Holy Grail?
Mm-hmm.
Blue, no, red. Did I write? Got me going on that one. 12. So, final answer. It says find the domain, so how do you write it?
It would be
You
0,
can either write the whole word domain or just D.
0,
Squiggly.
8, negative 12.
0, 8, negative 12.
Squiggly line.
And there's your domain. So for the range of 5, negative 1, and 14, our domain is 0, 8, and negative 12. Yay! Not that bad, right? A little busy work. But this actually saves you a lot of time because over here, all I did was a bunch of calculations. I didn't have to do any algebra. I did all my algebra on the left and then just did math. Arithmetic, to be precise. Let's do one more thing. What time is it? Oh, we got plenty of time. Let's do a couple more things.
I feel like more of that scene from Spinal Tap, where they're stuck in the basement.
You know, I've never seen that movie. All these years I've been meaning to. Graph f of x is equal to 2x squared minus 7. I have no idea if this is going to work out nicely, but that's okay. On the test, I'll make it. So if I ask you to graph this, number 1, is it linear? What makes a graph linear?
It is.
It has slope. Does this thing have slope? Nope. Has no slope whatsoever. Why is this not linear? Because it has a square. So, just because of this piece right here, this thing cannot be linear. That means when we graph this, it is not going to be a straight line. It's going to be a parabola or some kind of graph. I can make that cube and really mess you up. Or even worse, make you use your calculator and put square root or something weirder. So how am I going to graph this thing?
Oh, no,
Solve for y.
You couldn't factor it anyways.
Solve for y.
It's already, well, y is already solved for. See, f of x is the same thing as y. So this is y equals 2x squared minus 7 if you wish. If you don't know how to graph something, what should you use?
Table.
A table. So let's use a table. Now on the test, I'm going to tell you the domain that you're supposed to use. For now, though, I'm not going to. I'll tell you what's the smallest value to use and what's the largest value to use. So here goes the domain, also known as what kind of variable? Independent. And here goes the range, also known as? Dependent. And then up here goes the function, Notice I've replaced the x with a bunch of empty parentheses. One of my favorite things to do. All right. We can kind of guess what kind of values we can use. If I plug in -5 in here, is that going to help me?
No.
No, because that becomes 25. 25 times 2 is just too big. So -2 maybe?
Okay.
2, -2. That sounds good. -2. So this becomes 2 times -2 all squared minus 7.
Or it'd be 8 minus 7.
8 minus 7 is 1. Hey, that's not bad. Or if I could use -3. That'd be 9, 18. That'd be 11, but that's okay. -1. Once you find one that works, just go in order. -1 squared minus 7. That would be what?
7 would be -5.
-5. 0?
Be -7.
Be -7. I don't even have to do any work for that one. 1?
-5.
Would be 2 times 1 squared minus 7, better known as -5. 2? 2 squared, 2 times 2 squared minus 7 is equal to 1. Let's just do 3 for the fun of it. 3 squared minus 7 is better known as 11? 9, 18, 18 minus 7, 11. And that's enough points to graph this. I trust you. So, now let's put it over here. It actually takes up too much room. 1, 2, 3, 4, 5. 11 right there. And 1, 2, 3, 4, 5, 6, 7 down there. So plot -2, 1. Where do you go?
Left 2.
Left 2.
Up 1.
Up 1. And -1, -5.
Left 1.
Left 1.
Down 5.
Down 5. And 0 is -7.
Down 7.
Just goes straight down 7. And 1, -5.
Right 1 down 5.
And you'll notice we've started repeating values already. 2, 1.
Right 2.
And finally 3, 11, way up here. So more than likely -3 is also right there.
Somebody's in the bathroom.
Mine.
What are you doing over there?
And finally, we assume that there's an infinite number of points that will follow the exact same pattern. And for your purposes, this is an assumption, a very big one. There. That looks a little bit better. And of course, it goes on forever up. That's a pretty picture. All right. How about this one? Might as well throw a cube in there. Be anything. Table. So independent variable, the domain. Dependent variable, the range. And the equation is going to be something minus 2. Find that first and then cube the whole thing. Something minus 2, cube the answer, and that'll become your range. What number do you want to try? Well, back up to -5 and see if that works. If you plug in -5, -5 minus 2 is? -7, -7 cubed. It's like 243 or something like that. That's way too big. Shrink it down. -2. -2 minus 2. -4 cubed. 64. It's still too big. 0.
Hey, I like that number.
I like that number too because 0 minus 2 is
-2.
Negative 2 cubed is negative 8. So I'm going to choose negative 2, and we're going to get 0 minus 2 cubed is negative 8.
No, we started doing it.
Okay, never mind. 0. So the next number will be 1. 1 minus 2 all cubed. What is it? What kind of 1? Negative 1. So it'd be negative 1. If I plug in 2, 2 minus 2 cubed, 0. If I plug in 3, 3 minus 2 cubed, 1. If I plug in 4, 4 minus 2 all cubed, 8. If I plug in 5, 5 minus 2 all cubed, 27. That's generally just too big. But here's the thing. If I keep going positively, what happens with my answers?
Bigger.
They keep getting bigger and bigger and bigger and bigger. They don't stop going. They don't come back down. All right, we can graph this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Gonna find out where he is. All right. So where do I start?
0.
0.
8. So but we left -8.
Down.
Down 8. Damn.
What did I tell you about that? 0, left, right, down, 8. Down here. It's a y-intercept. 1, negative 1. Right 1, down 1. 2, 0.
Right 2.
What kind of intercept is this?
X Intercept.
X intercept. 2, 0. 3, 1 would be right 3, up 1. 4, 8 would be 4 to the right and up 8. This is actually kind of a cool graph if you think about it. Comes down, flattens out a little bit, then it keeps on going down forever. And that's called a cubic. Interesting. This is called a quadrant. Graphing. I feel like I'm forgetting something. I just don't know what it is.
I think you should give us your test out now and let's practice
Give you
on
your
it.
test now?
Let's practice on it, and then tomorrow we'll come in and take the real thing.
I'm not ready yet.
I'm working. Well, I'm working on it. You guys are working with me.
Did that. What's the definition of a function? Because I could ask that. Definition of a function.
Does
Vertical line test. A vertical line can only hit the graph of a function once, but that's not the definition of a function. That's just a test to prove that something is a function or not. Like for instance, is this a graph of a function? Well, yeah, because a vertical line passes through it only once. Is this a function? Well, yeah, because I said it was a function to begin with. But if I gave you a graph, well, let me erase these. Have you found the definition yet? What is it?
It's a relation where every x has only one y value.
For every domain, there is only one range. In other words, the domain never ever repeats. Ranges can repeat all they want. Domains can't. So, let's see. If I give you this set of points, let's call it A. -2, 1, 5, -7, 0, -1, 2, 3, 1, and 4, -8. Is this set of ordered pairs a function?
Yes.
Why?
Because none of the domains repeat.
Because none of the domains repeat. Here you have -2, here you have +5, here you have 0, here you have 3, here you have 4. I could care less, which number did I repeat? 1. I could care less that the y values here are repeating. Care less about that. It's the domain you focus on. The domain values cannot repeat. So this is a function. It is a function. Alright, what was the other thing I was going to do? Oh, a couple graphs. Is this the graph of a function? Are you sure? Because that horizontal line's hitting it 3 times. You don't care about that. It has to be vertical. Every vertical line that you could possibly draw through this graph will only hit it once. So this is a function. By the vertical line test, you have to tell me that, by the way. You can't just guess it's a function or it's not. You have to tell me why or why not. Line, V line, hits only once. Yes, you have to tell me that. Otherwise, you're just guessing, and I don't take guessing. Is this the graph of a function? No, without a doubt it is not. Because all you have to do is pass a vertical line right here. And you hit the graph once, twice, 3 times. Oh, none of you would probably remember that. Lionel Richie, way back when. Nah, never mind. So, this one is not a function. V line hits more than once. V line hits more than once. And that's it. That's all there is to determining if a graph is a function or not.